Section 3.4 is called Advanced Factoring. So we're going to factor using some more diverse strategies than we had in Unit 2. Part A is going to focus on factoring sums and difference of cubes. There's a pattern for factoring the sum or difference of cubes, and to be able to factor these, I really need to know this formula or this pattern. This is a formula that would show up like on a formula sheet on your final. It's on the final exam formula sheet if you went to look at it. But the formula is a cubed plus b cubed factors into a plus b times a squared minus ab. Oops, oh goodness, I meant to put the plus here for the last term. Plus b squared, then close the parentheses. It's really sloppy looking. So that's a plus. Accidentally closed my parenthesis earlier, I'm not sure why. So a plus b times a squared minus ab plus b squared. Okay. Now the difference of cubes is similar. It's going to start with a minus b instead, and then it's going to have a squared plus ab plus b squared. So I want to use these formulas to factor each of these problems here. So the first one, x cubed plus 27. I first want to identify what a is and what b is. A is just x, because x, when you cube it, gives you x cubed. B, harder to see, b has to be whatever it is that you would need to cube to get 27, because 27 is the result, b cubed. So b is going to be 3, since 3 cubed is 27. Okay. I'm going to use the sum formula, because this one's a sum. So this is going to factor into x, a, plus 3 times x squared minus a times b, x times 3, so 3x, and last plus b squared, and b is 3, so b squared, 3 squared is 9. When you factor something from a sum or difference of cubes, the trinomial that you get should be prime. You check. You can't break 9 down to get 3 as the sum, so this is completely factored. Okay. Let's look at the next one. Okay. In the next one, a is, well, a, because a cubed gives me a cubed, and b is what number I would need to cube to get 125. So in this case, 5. I don't take the negative as part of b. The negative just indicates which formula to use. I'm going to use the difference formula here. So I have a minus b, so that's going to be a minus 5 times a squared plus ab, so plus 5a, plus b squared, 5 squared, so plus 25. So factoring a sum or difference of cubes is a matter of applying the formula for factoring a sum or difference of cubes. Now the next two get a little more interesting. So I'm going to start with, let's see, the a value. There is a number and a letter in that first term, so I want to know what number cubed gives me 8. That's going to be 2, and what letter cubed gives me x cubed, that would be x. So I'm going to have 2x for A. And for B, what number cubed gives me 27? We already saw that was 3. And what letter cubed gives me y to the third? That would be y. So I'm going to have both a number and a letter in each of these. Formula works the same way. So I start with, it's a difference. I start with A minus B. So that's going to be 2x minus 3y times a squared. So when I square a, I have to square the entirety of a, both the 2 and the x. So a squared is going to be 2 times 2, so that's 4, x times x, x squared. So square the 2 and square the x. Then next comes plus a times b, so 2x times 3y, that's 6xy. Last, plus b squared, 3 squared, y squared, so 9y squared. Okay. In the next one, I need to figure out what a and b are going to be. Okay. A has to be whatever you would need to cube in order to get n to the 9th. So I'm thinking to myself, n to the 9th equals what cubed? Because I know that powers multiply, it had to be n to the 3rd cubed. So a would have to be n to the 3rd. N to the 3rd is n to the 9th. So the base of that exponent has to be n to the 3rd. And B, what number do you cube to get 64? That's going to be 4. This one's the subtraction again. So we're going to start with A, which is n cubed, minus B, which is 4, times, I need to square n cubed. So n cubed squared would be n cubed times n cubed. That would be, just as a note, n cubed squared would be n to the 6th, right? Because you're going to multiply your powers. So it would be n to the 6th. Sorry, I made a note down here just to show my work. But that would be n to the 6th. Then I would have plus ab, so 4n to the 3rd. And last, plus b squared, so plus 16. Okay. There's the potential on one such as this that you would be able to go further because you still have a cubic here. However, 4 is not a perfect cube, so you would not be able to find a b value. The a value would be n because n cubed is a perfect cube. Here, the 4 is not, so I'm going to have to stop. If it was, I would keep going. Okay. Next page. Now we're going to factor these following completely, so we're going to use all of the factoring strategies from Unit 2 in addition to the new one we just got here in Unit 3. So the first thing I notice is greatest common factor. So the greatest common factor is going to be 2 and x something and y something. So first of all, take out a 2, x fifth, x squared, so 2x squared, and y just to the first. Factor that out. Okay, if you do so, it would leave you with x, the 2's gone, so just x cubed, minus, and 128 divided by 2 is 64. You remove the x squared, and you remove one of the y's, so you have y to the 3rd. Right, I'm going to be able to factor further because this part of it is a difference of cubes. So let's see if I can have my difference of cubes formulas overlap with this page so I can see both at the same time. And I need to use those to factor. Okay, so A is going to be x and B is going to be 4y. Okay, so I'm going to have 2x squared y, just leave that part alone, a minus b, so x minus 4y, times a squared, that's x squared, plus ab, that's 4xy. I keep writing the parenthesis too soon there, plus 4y squared, so all of that squared, so 4 squared is 16, y squared. I'm going to rewrite that one just because it doesn't look so nice with my parenthesis in the middle. So 2x squared y times x minus 4y times x squared plus 4xy plus 16y squared. That's my final. Same thing I had written above, I just cleaned it up because that plus sign didn't look so nice. All right. And the next one. What I would do first is notice that my terms are not in the correct order because the highest power is not first. I always want to have the highest power first. So I'm going to rewrite this to start as negative 3x to the 4th plus 3x, just switch the order. Then I'm going to factor out my greatest common factor. So I can divide them both by, if the first term is negative, always a negative, then by 3 and by x. So if I divide out negative 3 and x, I'm just left with x cubed in the first position, and positive 3 divided by negative 3 is going to be negative 1, and I took out the x. This can be factored further because it's still a difference of cubes. The a value is x. The b value, what number cubed gives you 1? 1, because 1 times 1 times 1 is 1. Okay? So it's still a difference of cubes. So I'm going to have my negative 3x times a minus b, so x minus 1, times a squared, so x squared, plus ab, so plus 1x, plus b squared, which is still 1. 1 squared is 1. That's factored. Okay. The next one also has the same problem that part B did, and that it is not in the correct order. So we're going to reorder it first to write it as negative 27 y cubed plus 8. And then you always factor it'll lead to negative, even if that's the only thing you can factor out. So negative parentheses 27 y cubed minus 8. Now, again, it is a difference of cubes. So my a value is 3 for the 27. 3 cubed is 27, and y. and my b value is 2. I guess 2 cubed is 8. So my answer is negative. Don't forget to have your lead negative there. It's a subtraction, so a minus b. So 3y minus 2 times a squared, so 3 squared is 9, y squared, plus ab, 2 times 3, so 6y, plus b squared, which is 4. And part D. What I want to try to make sure that I notice in part B to begin with is, even though these are already perfect cubes, there is a greatest common factor, and you always want to do greatest common factors first. So what is the largest number that goes into both 64 and 1,000? So if you check, you can divide out by 2, 4, or 8. So 8 is a greatest common factor. We're going to have to factor that out first. It would be 8 times 8c cubed, and 1,000 divided by 8 gives you 125. So factor out your greatest common factor first. Then this is going to also be a difference of cubes with an a value of 2, since 2 cubed is 8, so 2c, and a b value of 5, since 5 cubed is 125. So my answer is 8 times, this is an addition one, so I'm going to have a plus b to start, so 2c plus 5, then times a squared, so 2 squared, so that's 4, c squared minus ab, so 2 times 5 is 10c, and last plus b squared. All right. Let's go on to the back side of this page. All right. Oh, part B.